So basically today's GFGP today we have a problem. Find the first node of loop in linked list. So basically it is a easy level problem, and here we have a question as given a head of the single linked list. If a loop is present in the list, then return the first node of the loop, else we have to return false or null. Okay, and here custom input is also given here, ahead of a single linked list and a position 1 based index which denotes the position of the node to which the last node points to. If position is equal to 0, it means the last node points to null, indicating there is no loop. So basically in the given problem, as if I'm talking about like in the yesterday problem we have to like check it for the list is having like loop or not. Okay, in the yesterday problem we have to basically check the list is having any loop or not. So first of all, here the approach is like simple. Here first of all we have to check that the linked list is having any loop or not. If the list is having loop, then we have to return the first node where loop is actually going to be started. Okay, so the approach is like really very simple. Like if I'm talking about the first example here, so 1 3 2 4 5 is my linked list, and after that 5, the loop is basically starting from 3. So here our output will be like 3. We can see that there exists a loop in the given linked list, and the first node of the loop is 3. Okay, similarly if you're talking about the second example here, so here no loop is actually formed, so that means here we have to return -1. Okay, so if there's no loop any so if there any loop exists in the above linked list, so here our output is -1. That means if the loop is not having, if the loop is not exist, then we have to return -1. So we need to solve this problem with a topic text like linked list, to pointers algorithms, data structures, and algorithm. And we need to solve the problem with an expected time complexity of order of n. That means while traversing all those linked lists, we have to perform the operations, and expected out space of like order of n. That means we don't have to use any extra spaces. Okay, so the steps to solve the given problem is like first we need to check whether the list is having a loop or not, right? So how we can get these things, if you remember the yesterday problem, then you can is able to understand this problem also, right? So here we have to solve this problem using two pointers. So first of all, I have to do node is tab pointer slow, okay, which I'm pointing at my head node in the initial stages. Okay, I have to create one more pointer, let's say fast, which is pointing to head node. That means in the initial point we have to create two nodes, both are pointing to the head node. That means the first node of the linked list, and then after that we need to traverse through fast node. Here we have to check the condition while fast and fast next is not going to be equal to null, then there what we have to do here, this is the basic condition of fast and fast next is not actually null. Then because fast is actually moving by 2x steps. Okay, so here we actually taking as a condition if fast and fast next is not equal to null, then here we actually giving the condition as slow is equal to slows next. That means slow is moving by one step. Okay, as we have done for yesterday's problem also. Okay, and fast is equal to fast next next fast next and then next. That means it is moving by 2x speed. That means if it is like if the first node is actually here, then the slow node is actually presenting out 3 node. If the fast node is like moving from 2 to 5, that means fast is moving by alternating nodes. Okay, yeah, then after that here we are going to check if fast node is like equal to, we can say that slow node. That means there in the study problem we have to return like to return true. That means it is having a loop, but here we have to return the node, so here we don't have to return true. Here we have to simply break out from this loop. Okay, or we can simply like create any variables and say that yeah, it is true. Okay, and here we can say that after just doing this thing we need to come out from this loop. Okay, and here we can say that if fast node is not equal to slow node, then here we need to return null. That means there is no any loop formation, that means false. Okay, but here we have to return type of node, so here to return null. Okay, now once we getting the idea that the loop is having the linked list is having a loop or not, we need to check. Now we need to check for the first node where the loop is actually found, where the loop is found. Okay, so for that what we'll do here, first of all, again we have to set our slow node as head node. Like after checking all those things, again we are pointing our slow node to this first node. Okay, and then after that here we are giving again the condition as like while fast. Okay, while fast we have to give the condition and we need to check it here. Here we are moving our slow node by one step, that means slow next. Okay, and here we have to also move our fast node by one step, that means fast next. Okay, and then after that here we have to simply return our fast node. Okay, let me compile and run. Okay, so here I've done mistake here as it is node, not capital O. Okay, let's try to again compile and run. So here I'm getting please optimize your code and submit again. So here I think I've done mistake here. Okay, so slow is equal to head. I am pointing my head node to this node and saying that if fast is not equal to here, like given a wrong condition, here we need to check it for if my slow pointer is not equal to fast pointer. That's the main thing. That means our slow pointer is not must be not equal to the fast node, because if fast node is like equal to slow node, that means here it is having loop. But here we don't have to find the loop. Here we actually here the condition is like if fast node is not equal to slow node, then here we have to move our slow node by one step and as well as fast node by one step, and we need to return the fast node. If it will be there, if the loop is actually there, then we can get our first node also. So yeah, here compilation is completed. Let's try to submit it. So it's submitted. So yeah, that's all for today. Thanks for watching.